Hi, 6th grade students. Today we are going to be marking the text in our textbook pages, so please make sure you take out your textbook pages that were given to you a few days ago. We are going to start by numbering our paragraphs on page 11. So looking at your textbook pages, we have 3 paragraphs on this page, paragraph 1, paragraph 2, and paragraph 3. So please number those now. We're going to flip to our next page, which is page 12. We have paragraph 4, which starts with wavelength, paragraph 5, and paragraph 6. Finally, we do have one more page we need to read, so I'm going to flip to page 13, and we have paragraph 7 and 8. Please pause this, and when you are ready to press play when all of your paragraphs are numbered. Looking back at the front, I'm going to start by reading each paragraph. After I read the paragraph, you are going to have to mark the text. Now, it is going to be your turn after I finish reading to mark the text yourself, and then you'll have a question to answer. So we're going to zoom in on paragraph 1. It says, what are the amplitude, wavelength, frequency, and speed of a wave? So here we go. Paragraph 1. Waves may vary greatly. For example, waves can be long or short. They can carry a little energy or a lot of energy. They can be transverse or longitudinal. However, all waves have common properties: amplitude, wavelength, frequency, and speed. Okay, it is your turn to find the important words in that paragraph. Now, I'm still going to read this bolded part, and that should help you figure out what's important. So it says, amplitude describes how far the medium in a wave moves. Wavelength describes a wave's length, and frequency describes how often it occurs. Speed describes how quickly a wave moves. Okay, now we are going to mark the text, and you need to check to make sure you have the same things marked. So in this paragraph, our important words are going to be those 4 parts of a wave. So I am going to circle my important words, which is amplitude, wavelength, frequency, and speed. Now luckily, all of those 4 words are in my main idea sentence, and they even gave us this key to tell us that's our main idea sentence, so I'm going to underline those sentences. Okay, we are going to do the same thing with paragraph 2. Again, you will have to pause, it will pause when I'm done reading it, and you have to mark the text for yourself and then answer questions. So it says amplitude. The height of a wave's crest depends on its amplitude. Amplitude is the maximum distance the medium vibrates from rest position. For a water wave, this distance is how far the water particles move above or below the surface level of calm water. High waves have more energy than low waves. The more energy a wave has, the greater the amplitude. It is now your turn to mark the text. Alright, scientists, now that we're back, you are going to check to see if you have the correct thing circled and underlined. So we know this paragraph is about amplitude because that is the title, so that is one of our important words. Now we do have to describe what amplitude is, and this is also from our vocab. So we know that amplitude is the maximum distance from rest position. And we also know that it is the height of a wave. Now, please be careful because it does give us an example of water wave, but that is an example, which means it is not the main idea sentence. Our main idea sentence is the definition of a wave, which is amplitude is the maximum distance the medium vibrates from the rest position. Okay, we're on paragraph 3. We are doing the same thing. So I'm going to read it. You are going to answer a question and mark the text, and then it will play again when you are ready to check your answers. A transverse wave is shown in figure 1. Its amplitude is the maximum distance the medium moves up or down from its rest position. The amplitude of a longitudinal wave is the measure of how compressed or rarefied the medium becomes. When the compressions are dense, it means the wave's amplitude is large. Now, we are not going to make you mark the text for this paragraph, but we are going to do this below. So it says amplitude. The amplitude of a transverse wave is the maximum distance the medium vibrates from rest position. Label the parts of the wave, then answer the question. Measure what is the amplitude, and then it says what is the amplitude of the wave in centimeters. Now, we do not have to do number 2, but you do have to label. So it gives you boxes. It tells us what the rest position is. So right now you are going to do this by yourself and answer 2 questions. So it is your turn, and then when you play again, it will give you the correct answers. So looking at this, we have the rest position. The bottom of the wave has that U shape. Here's that U, which we know is where animals feed out of, which we call the trough. Now the top of the wave, which is right here, the top of our wave, is what we call the crest. Now we also want to label where our amplitude is, and we can measure that from rest position to crest. So this is my amplitude. Okay, we are on our next page, so please flip to page 12. Okay, looking at page 12, we are looking at paragraph 4. So paragraph 4 starts with wavelength, which gives us a really good idea of what this paragraph is about. I will read it. It is then your turn to mark the text. So it says wavelength. A wave travels a certain distance before it starts to repeat. The distance between two corresponding parts of a wave is its wavelength. You can find the wavelength of a transverse wave by measuring the distance from crest to crest as shown in figure 2. For a longitudinal wave, the wavelength is the distance between compressions. Okay, again, it is your turn to mark the text. You will answer some questions and then it'll come back and you can check your answers. Please make sure that if your answers are not correct, you fix them. Okay, now that you are back, we know that some of our important words are wavelength, and we also know that because that's the title. We also want to find words that help describe what the wavelength is. We know the wavelength is the distance, and it's the distance between two corresponding parts of a wave. Okay. It also talks about how you measure the distance from, and then it says crest to crest. So those are the things we should have circled. Our main idea sentence is that definition of wavelength, which is the distance between two corresponding parts of a wave is its wavelength. So we want to make sure we have that underlined. Paragraph 5. The frequency of a wave is the number of waves that pass a given point in a certain amount of time. For example, if you make a wave on a rope so that one wave passes by a point every second, the frequency is 1 wave per second. Move your hand up and down more quickly and you will increase the frequency. I'm going to read paragraph 6 as well, and then you are going to go back and do both of those. Frequency is measured in the units called hertz and is defined as the number of waves per second. A wave that occurs every second has a frequency of 1 wave per second, or 1 hertz. If 2 waves pass every second, the frequency is 2 waves per second. Now, when it is your turn, you are only going to mark the text for paragraph 5. You do not have to mark the text for paragraph 6, okay? All right, it is your turn. Okay, coming back, we know that this paragraph is about frequency because our title is frequency. So we want to find words that talk about what frequency is. So frequency is the number of waves that pass in a amount of time. Okay, now again, it gives an example which tells us we know that's not our main idea sentence. Our main idea sentence is that definition of frequency. Now, in paragraph 6, I didn't ask you to do this, but I would like you to box that word hertz. Those are the units that we use to measure frequency. Now, looking up above, it's asking us a few questions, and it says properties of a wave. All waves have amplitude, wavelength, frequency, and speed. Okay. Now, we are looking at 2 different waves. Okay. It wants to know name the transverse wave, which transverse wave has the shortest wavelength. Okay. Now we know that wavelength has to do with the distance between 2 parts. Okay. So we want to know which of these is shorter. So when we look at this, we are going to measure from crest to crest. Okay. We are also going to measure from crest to crest. Okay. Now, to actually measure this would be difficult, so I'm going to help you with this one. We would know which has the shortest wavelength because when we measure from crest to crest, it would be shortest. So for this one, we do not have to answer number 1, but I did want to go over that with you. Okay, so you do not have to answer number 1. Alright, I did want to go over this picture with you though. I want you to understand that a transverse wave is this wave right here, and a longitudinal wave looks like a slinky. Now we are not grading you on any of that, but that is good information to have. Okay, we are going to flip to our very last page, which is page 13. So I'm going to flip one more time. I am now looking at paragraph 7 and 8 that talk about speed. Okay, scientists, so again, this is our last page, and again, this page is about speed. So as always, you are going to mark the text. After I read the paragraph, it's going to pause and ask you some questions. You are then going to check back to make sure you have the correct answers. So it says speed. Different wave speeds travel at different speeds. Different waves travel at different speeds. Think about watching a distant thunderstorm on a hot summer day. The thunder occurs the instant the lightning flashes, but the light and the sound reach you seconds apart. This happens because light waves travel much faster than sound waves. In fact, light waves travel about 1,000,000 times faster than sound waves. So it is your turn. You are going to pause it. You are finding the important words that probably talk about speed. You are finding the main idea sentence. Okay, now that we're back, we are going to circle our important words. Now what's tricky about this is this whole thing is an example, okay? But we do want to know that waves travel at different speeds, okay? And we now know that light and sound travel different amounts. So you're going to underline this first sentence. Different waves travel at different speeds. Okay, we are now reading our last paragraph. Woo! We're almost done. So I'm going to read this. You are then going to have a few questions. You will then go back and check to make sure your answers are correct. So the speed of a wave is how far the wave travels in a given amount of time. You can determine a wave speed by dividing the distance it travels by the time it takes to travel that distance. Sound, for example, travels about 990 meters in 3 seconds. In air, when the temperature is 0 degrees. Therefore, its speed is 330 meters per second. In these conditions, as long as the temperature of the medium doesn't change, the speed of the sound will stay the same. So again, it is your turn. So you are going to have the video paused, and you are going to mark the text. So we want to circle speed, and we want to circle that the wave travels in a given amount of time. This is also a math equation, so we can find speed by dividing distance by time. Okay, so we are actually going to underline this first sentence. It's our main idea sentence. Now that we are done marking the text, we have just a few questions that we need to answer. Please use your vocab and your text to help you with this. It says, now I know that for any wave, amplitude describes, wavelength describes, frequency describes, speed describes. It also says, I need extra help with. You are going to answer these questions based on your text. So it is your turn. Answer these questions. When the video starts again, you will get the answers. So amplitude describes the height of the wave. Wavelength describes length. And I'm going to write crest to crest. Frequency describes the number of crests. And speed describes, just like it says over here, right, how far a wave travels in a given amount of time. So distance by time. All right, scientists, congratulations. You have finished marking your text. Now that you are done with this, we can see your answers after you submit it, and it is important to us that you get this correct. When you are done with this, you are going back on Google Classroom and you are studying for the Quizlet because you will have a quiz on this soon. Enjoy your 3-day weekend, and we will see you on Tuesday.